Dear students, I am Mahesh Javalkar of Maratha Mandal Polytechnic, and today we'll see how do you form the VI characteristics of SCR. Okay, so this is the first diagram. What is shown is a symbol of SCR. So here you can see the symbol of SCR. So symbol shows that you are having anode. Anode is a terminal over here. Anode, you are having gate, and you are having cathode. So anode, cathode, and gate, which can be structurally shown like this. You can have structure like this. You can have 4-layer device. You can have P1, then you can have N1, you can have P2, and then you can have N2. Okay, so this can be your anode terminal. This will be your cathode terminal, and here is where you're going to give the gate. Okay, so this is how the structure and the symbol of SCR looks. Okay, then after this symbol and structure, we know what do we mean by forward bias. What do we mean by forward bias? So forward bias will be a condition where the anode of the SCR is made positive. Anode of the SCR is made positive with respect to cathode of the SCR. So this is the cathode of the SCR. So here you can see this is plus, this is minus, this is voltage between anode and cathode. Okay, so when anode of the SCR is made positive with respect to cathode of SCR, then it is called as forward biasing. Okay, so next, if you see this structure over here, okay, so here P1, N1, P2, N2 we have shown. Now here you can see that if you want to forward bias, then this anode should be connected to the positive of a battery. If you show this battery, anode should be connected to positive battery and cathode should be connected to negative of a battery. Okay, so here if you see, this is negative, and here if you see, this is positive. Okay, this is positive. So this is your voltage between anode and cathode. Okay, if you apply this kind of biasing, then it is called as forward biasing of SCR. Okay, then what happens in forward bias? Okay, so if you show this type of circuit over here, so here you can see you have connected positive to the anode and negative to the cathode, and the gate is shown open. Over here. Okay, so here you can see your gate is shown open. So here you can see open gate. Okay, open gate. So only you have given this as positive and this as negative. Okay, through this battery. Okay, here you are having this battery connection, and here you are having this battery connection. So it is forward bias. Okay, now when you do this, when this type of voltage is applied across SCR, then if you concentrate on junction 1, that is between P1 and N1, this junction, okay, so this junction P1 is connected to positive and N1 is connected to negative, so it is forward biased. Okay, this junction, that is between N1 and P2, now N1 will be connected to positive and P2 will be connected to negative. This is reverse bias. Okay, and this junction J3, P2 is connected to positive and N2 is connected to negative. This is forward biased. Okay, now you have a junction, first junction as forward bias, second junction as reverse bias, first junction as forward biased. Now your anode current is going to flow like this. This is the flow of your anode current. Okay, it will flow from anode to the cathode. Okay, this first forward bias and the junction J3 forward bias have no problems. They will allow the current to flow. But the second junction, which is reverse bias, will not allow the current to flow. So here there will be a very small current flowing because of minority charge carriers, which can be like your leakage current in a diode when it is reverse bias. Okay. So here what happens? If you draw a graph for this, okay, if you draw a graph for this, you can see that the graph will be drawn in the first quadrant. Okay, so if I draw a graph here, graph I'll be drawing in the first quadrant. Okay, first quadrant graph, and the graph will be between the voltage VAK, okay, and the current anode current IA. Okay, now here the voltage VAK will not be the applied voltage, it will be voltage across the SCR. Okay, and this will be the current, anode current, which is flowing through the SCR. So this is your 0 point. Okay, so once you apply this voltage, this graph, because the first junction is forward biased, second junction is reverse biased, okay, and third junction is forward biased, it is going to remain here only. It is going to remain here. There will be no flow of current. There will be a small leakage current as you go on increasing the voltage. There will be a small leakage current here. So this type of graph will be called as, this type of area of the graph will be called as forward blocking state. Okay, forward blocking state. Now this is what is happening when you have this type of circuit, forward blocking. So the current is not increasing because the second junction is not going into breakdown. The second junction is having a minority charge carrier leakage current, very small current. The first junction and the third junction support the flow of current, but the second junction is having a very small current. So there will be no rise in the main anode current of SCR. SCR is still not made on, it is in a forward blocking state where it has not triggered, it is not become on. Okay, then if you see, if you apply a gate pulse, okay, if you apply a gate pulse, now in this diagram we have shown that you are having against the same junction, you are having, this is forward biased, junction J2 is reverse biased, and junction J3 is forward biased. Okay, so this voltage is applied, anode is made positive, cathode is made negative over here. It is made negative, and then you can see that there is a application of gate also. Now gate you are applying here, so here you are applying a gate pulse. So this is a positive pulse you can apply here. So if you apply a positive pulse to this point, okay, this will make the second junction, that is junction J2, this junction will go into breakdown little early. Okay, or it will go into breakdown. Okay, so if you draw a graph for this, okay, if you draw a graph for this, you can see that, say this is your anode current, this is your voltage across anode and cathode. Okay, so this is anode cathode voltage across SCR, this is anode current. So initially we had, this was 0, initially we had forward blocking state and it came somewhere here, but as you give the gate pulse, breakover takes place, breakover takes place, breakover takes place, and the voltage across the SCR will decrease and current will increase, current will increase. Okay, so here is where you are going to give the gate pulse. This is the breakover voltage, this is the breakover voltage. So this will be called as forward blocking state, and this will be called as forward conducting state, forward conducting state. Now this is happening because either you are increasing the voltage between anode and cathode too much high so that you reach the breakover voltage, or you apply the gate pulse so that breakover voltage is reached. So this voltage is reached. Okay, if you apply the gate pulse early, this voltage will be reached early. If you apply the gate pulse little more early, it will be here. That is where the firing of SCR or triggering of SCR will come into picture. But this is where your now this is the area where you are having forward conducting mode of SCR. Okay. Then we'll go to see what do you mean by reverse mode of SCR. Now in reverse mode of SCR, we have shown that your anode is connected to the negative of the voltage and cathode is connected to the positive of the voltage. Okay, so anode is connected to the negative and cathode is connected to positive. Okay, so here you can see anode is connected to negative, cathode is connected to positive, and gate we have kept it as open, so we don't need gate at this stage to show reverse blocking stage. Now here if you show the graph should be showed in the third quadrant. Okay, third quadrant. Now then this will be your voltage across the SCR. This will be in minus. This will be your current, which will also be minus, and this will be your reverse blocking state. This will be your reverse blocking state. Reverse blocking state. Okay, so this is your reverse blocking state. Okay, now this is one thing what happens, and again if you increase the voltage, okay, again if you increase the voltage, now what is happening in these junctions is that if you see these junctions over here, junction J1, J2 and J3 over here, okay, so you can see that junction J1 is reverse bias, junction J2 is forward biased, and junction J3 is reverse bias. So here you can see that P is connected to negative terminal, N is connected to positive, so it is reverse bias. Here N is connected to negative, P is connected to positive, so it is forward bias. So here J3, P is connected to negative and N is connected, so it is reverse bias. So forward bias has no problem for the current to flow, but both this reverse bias, if you want to make them to go into breakdown, junction J1 and J3, you want to make them to go into breakdown, then this voltage, negative voltage, has to be increased. If it is increased, then one stage will be reached, which will be called as breakdown voltage. This will be called as breakdown voltage, and here you can see the diode type of breakdown happening in SCR also. But this is the third quadrant. This is your reverse blocking state, and this is your reverse breakdown state. This is your reverse breakdown stage. Okay, reverse breakdown stage. After this, if you increase the voltage, the SCR might get damaged over here. Okay, but this is not the place where we use the SCR. We use the SCR in the forward state only, in the forward blocking and forward conducting state. Okay, now if you see all these graphs together, you can see the VI characteristics of SCR. Okay, now in this VI characteristics of SCR, if you concentrate on the forward stage over here, okay, so you can see this graph is going here, and this is where your breakover rate voltage is happening. Now this is where no gate is applied, no gate pulse is applied. Okay, no gate pulse is applied. It is happening just because you're increasing the anode cathode voltage and the breakdown of the second junction takes place. Okay, breakdown of the second junction takes place. Then here you can see this blocking will go like this if a gate voltage is applied. If the gate voltage applied is little early, then here only you are going to take a turn. If it is applied little more early, then here only you are going to get a turn. Okay, and then this will go like this, and then the anode current will increase and the voltage across the SCR will decrease. Okay, so this will be your forward conduction area, this area. Okay, and this is your forward blocking area. Okay, so this is your forward leakage current. Clear? And this is your breakover voltage. Okay, now in this only we have shown what is holding current IH and what is latching current. Okay, so holding current is the minimum forward current below which if the current goes, SCR will turn off, and latching current is the minimum forward current above which the SCR is going to be on. Okay, so always holding current will be little less than latching current, but they will be near to each other. Clear? But now anyway, once you apply a gate pulse, or once you reach a breakover voltage by increasing your anode cathode, now your voltage across the SCR will decrease and anode current will increase. Okay, now here we say SCR is on, SCR on. Okay, so here SCR was not on, SCR was off here. SCR was off, but it was about to on, it was forward blocking. But here you can say SCR is on. Okay, and even in the reverse bias, you can see here it is leakage current of the junction first and third, and here once the breakdown voltage is reached, this is reverse breakdown. This is reverse breakdown. Okay, this is reverse breakdown in which the J1 junction and J3 junction will go into breakdown, whereas the J2 junction is already forward bias, and this kind of breakdown occurs. This kind of breakdown occurs. So what we have shown here. Okay. Now this breakdown will occur if you increase more, then the SCR here might get damaged. SCR here might get damaged. Okay. So here if you increase, the SCR might get damaged. So this will be your VI characteristics of SCR. SCR is operated in the first quadrant in forward blocking state and then forward conduction state, and in the third quadrant in reverse blocking stage, and after that reverse breakdown stage. Okay, now in all the applications the SCR will be used in the first quadrant, and in that also whenever the breakover voltage reaches, whenever the second junction goes into breakdown, because in forward bias the first junction and third junction are a forward bias only. Okay, so whenever the second junction goes into breakdown, the SCR starts conducting. Now that breakdown can happen if you increase the anode cathode voltage to a larger value, which is practically not possible. But if you have anode cathode voltage to a minimum value and if you apply a gate pulse, then the second junction will go into breakdown early and SCR will show conduction. This thing will start on. SCR will become on. Okay, so same way, if you give the gate pulse early, it will conduct early. It will become on early. So depending on when you are going to give the gate pulse, the awning or firing or triggering of SCR depends. Okay, so then once it is triggered, then the voltage across the SCR will decrease and current will go on increasing. Current will go on increasing. So the graph comes behind for voltage and then increases for the anode current. Okay, so these are the VI characteristics of SCR. Okay, thank you students. Hope you have understood the VI characteristics of SCR. If you're having any doubt or if you want to give me any feedback, you can leave a comment on my site. Okay, thank you very much.